Hello, Integrated Math 1. Welcome to lesson 1.1.2. Of course, before we jump into today's lesson, we do have a warm-up here to get just started, to get everything going. So, also you should be aware that in addition to your workbook and a pencil, you are going to want a pair of scissors today. That's going to come in handy in our activities. So here we have our lovely warm-up. There we go. I would like you to take a look at this. We've got 6 coordinates. And I would like you to write the coordinates of each point. Remember, we have an x coordinate and a y coordinate. It's always side to side first, up and down second. That's how it goes. And then I'd like you to name the quadrant or axis. If it's not in a quadrant, if it's on the line, it's on an axis. Name the quadrant or axis where the point is located. So just a quick reminder, quadrant 1, 2, 3, 4, or x-axis, y-axis. So go ahead and hit pause, give me the coordinates in the quadrant or axis, and then go ahead and hit play to check your work. All right, guys. So first of all, just to help remind myself, because my brain can only do so much. No, go back. My brain can only handle so much. I'm just going to remind myself this is quadrant 1, quadrant 2, quadrant 3. We like to use Roman numerals for these guys. And quadrant 4. We do like to use Roman numerals for our quadrants. So let's start off with point A. It looks like we had, now notice we're counting by twos, so I hope you were careful about that. So it looks like we go 2, 4, 5 over and then up 2. And of course we're in quadrant 1. So the coordinates for point A is 5, 2, quadrant 1. For point B, it looks like we go right 2, but we don't go up or down at all. So that means our point is 2, 0, and of course we are on the x-axis. So this guy's not actually in a quadrant. He's on an axis, and that's okay. For point C, it looks like we go right 1, but then down 4 to put us in that fourth quadrant. So that means point C's coordinates are 1, -4, and we're in quadrant 4. Sorry, my lights are always doing funny things in here, guys. Point D, it looks like we had to actually go left 5, so that's a -5, and then up 2 to put us in quadrant 2. So -5, 2 for quadrant 2. For point E, looks like we didn't go side to side at all. 0 side to side, but we did go up 6 to give us a point of 0, 6 and leave us on the y-axis. We actually didn't make it into a quadrant, didn't get off the axis. That's how it goes sometimes, and that's okay. And last but not least, point F, it looks like we had to go left 8 and down 8, so -8, -8, to put us into quadrant 3. There you go. Good times. All right, guys. So we're getting used to graphs again. We're getting used to writing coordinates again. We're getting used to our quadrants, right? We're getting used to where things go again. So today we're going to start analyzing and sorting graphs. It's almost like having a deck of cards. We're going to be playing with these guys today. So our goals today are to review and analyze graphs and graphical behavior, to determine similarities and differences among various graphs, to sort graphs and give reasons for the similarities and differences between the groups of graphs. We don't have any key terms this time around. No new words for you today, just old ones, right? That's how it goes. So you use graphs to analyze the relationship between independent and dependent quantities, right? In our last lesson, that's what we were doing. We were like, oh, hey, my independent quantity is always my x-axis. My dependent quantity is always my y-axis. And we were like, hey, the x is always the independent, y is always dependent. And we thought that was kind of cool and very convenient. But of course, let's start digging a little deeper. Do the graphs of certain types of relationships share any characteristics? So we're going to be sorting graphs. Mathematics is the science of patterns and relationships. Looking for patterns and sorting patterns into different groups based on similarities and differences can provide valuable insights. In this lesson, you will analyze many different graphs and sort them into various groups. So here's what I need you to do first, and this may take a few minutes for you to do. I want you to cut out a whole ton of graphs. So if you go over to pages M129 to M135, so there's actually 1, 2, 3, 4 pages worth of graphs. I would like you to cut out all of these graphs. Cut along the dotted lines. Don't cut off the letters. Don't cut off the letters. Don't cut off the labels. That's sad. But I would like you to cut all of these out. That's why I said you were going to need a pair of scissors today. So go ahead and hit pause to cut out all your graphs and then hit play so that we can start playing with them. All right, you got all your graphs cut out? Awesome. Let's move on. By the way, not only are we going to be using the graphs for this lesson, we're going to be using the graphs for the next lesson as well. So don't toss them out when we're done at the end of the day. We're not gluing them in, but we are going to use them for the next round. So watch out for that. So you've cut out all 19 graphs at the end of the lesson. There are 19 of them. Now I would like you to analyze and sort the graphs into at least 2 different groups. And you may group the graphs in any way you feel is appropriate, but I want you to take your graphs and I want you to sort them into at least 2 groups. You can actually do more groups if you like. That's okay. But at least 2 different groups, I want you to sort these out. And once you do that, I want you to do the following. For each of your groups, I want you to do this. I want you to record the following information for each of your groups. I want you to name your group. And don't name it Fred. Name it something based on what you're looking at, okay? Or maybe you could just name it Group 1. I don't care. Or maybe you do want to name it Group Fred. Who am I to judge? So name each group of graphs, and then I want you to just list off the letters of the graphs in each group. This is on page M122. You have some space for this. And then it says provide a rationale for why you created each group. That just means tell me why you've made this group that group. When it says provide a rationale, it just means give me a reason. Tell me why. So I'm going to give you just a few minutes. Again, you've got all 19 graphs that you've cut out. I want at least 2 groups. You can have more. And then just on your paper, name your group. Tell me what letters of graphs are in that group and tell me why you group those guys together. That's all we need. Go ahead and hit pause to do that and then hit play to keep the conversation going. All right, now, as you probably guessed, your groups, my groups, they're all gonna look different. And so we're gonna do here is we're gonna explore a couple of different groups. So in this activity, we're gonna consider the different ways that graphs are grouped. So we have some people that group their graphs in different ways. They have reasons for why they put graphs together in the same group. And we're gonna explore that a little bit. So on page M123, we have Matthew. Matthew grouped these graphs together, E, I, L, and R. Matthew grouped these graphs together. Why do you think Matthew put these graphs in the same group? Go ahead and hit pause and jot down your thoughts and then hit play to keep the discussion going. So I don't know about what you noticed, but what I noticed is there weren't any lines. I noticed they were all dots. Did you see that? Dots, 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 dots. I mean, don't get me wrong. Some of the dots kind of make a line, but there were no like connected stuff. Nothing was connected. So that's what I noticed about Matthew's group. The graphs have points that are not connected. I don't know if that's the reason he chose or not, but that's what I notice about Matthew's group. What about on the next page? What about Ashley's grouping? So Ashley has graphs C, E, J, Q, and S. And here's what Ashley said. Ashley said, I grouped these graphs together because they all have a vertical axis of symmetry. If I draw a vertical line through the middle of the graph, the image is the same on both sides. Ooh, Ashley. So Ashley says if you draw a line in the middle of the graph, the left side mirrors the right side, all that good stuff. All right, Ashley. Can you show me why Ashley's reasoning is correct? Can you draw those vertical axes of symmetry on each graph to show me that you can draw a line in the middle of the graph where the two sides mirror each other? Go ahead and hit pause to do that and then hit play to keep going. All right, so I noticed on C, I could draw a line right down the middle. Sorry, it's a little off, but I could draw a line right down the middle, and that way the left side mirrors the right side. Even this one, even though it was dots, I could draw a line right along the y-axis to get an axis of symmetry, and the left side matches the right side. Same thing with J. Q was a little different because these first three, my axis of symmetry was right on the y-axis, but that's not true on Q. I had to shift it over a little bit, but I could still draw a line. I mean, it was at 4 instead of at 0, but I can still draw a vertical axis of symmetry such that the left part matches the right part. And that's even true for S. I had to shift it a bit to the right. And while it doesn't look like it mirrors it, you've got to remember that this line keeps going. Remember that a little arrow, little arrow means that it goes forever and ever and ever, and that's not a very good drawing, but that means technically the left side can now match the right side. Yeah. So each of the graphs can be divided in half by drawing a vertical line, just a line right down the middle to split it in half, and then the two sides mirror each other. So cool. Love my axis of symmetry. You know, Ashley picked some that had a vertical axis of symmetry. We could draw a vertical line right down the middle to show the two sides mirrored each other. But there are more. Can you take a look through your stack of graphs? We already have C, E, J, Q, and S. You can set those aside. Can you look through your stack of graphs and see if there are more graphs? Identify other graphs that have a vertical axis of symmetry. Go ahead and hit pause to see if you can spot them. And you can just write them on your paper. Just write the letter of the ones you find on your paper, and then go ahead and hit play to keep going. I found a whole bunch. I found graph B. I could draw a line right through the middle and it would mirror on both sides. Graph D. Did you think of this one? I know it's a circle, but you could draw a line right down the middle and the two sides would mirror each other like a little butterfly. Graph H. Graph N. I have to shift it over a little bit to the left, but I can still make a line through it. And graph R. Do you think of graph R? That one was a weird one, but I could draw a line right down the middle and the two sides would mirror each other. That is something we could do. So I'm going to write down, because I don't want to glue these in. Remember, we want to keep using them. So I'm going to write down graphs B, D, H, N, and R on my paper so I can keep using graphs. Let's talk about Dwayne on the next page. Dwayne's got something incorrect going on. So I'd like you to consider Dwayne's incorrect grouping. So he has these lovely graphs here. And Dwayne says, I grouped these graphs together because each graph goes through only 2 quadrants. And you see the thumbs down. Something's not quite right about that. Dwayne says all of these graphs only go through 2 quadrants and no more. Why is Dwayne's reasoning not correct? Explain why Dwayne's reasoning is not correct. Hit pause. Tell me what's gone wrong here, and then hit play to keep the discussion going. One, 2 quadrants, 1, 2 quadrants, 1, 2 quadrants, 1, 2. Wait. There's an arrow on Q. Do you see that? On Q, there's an arrow. It's going to keep going. It's going to keep going. We just talked about that. Arrows keep going. Sorry, that again, bad drawing. It's not going to be in 2 quadrants. Q is going to be in 1, 2, 3 quadrants. So even though it's not visible, that arrow on graph Q, it's going to continue into the first quadrant. So therefore, graph Q goes through 3 quadrants, not 2. I can see why Dwayne thought it was only 2, but don't forget, arrows means it goes forever, and that means eventually to end up in a 3rd quadrant. Okay. All the others were fine. CJM, they were fine. Dwayne's reasoning, they satisfy Dwayne's reasoning of 2 quadrants. So again, there's probably more of these. So if possible, identify other graphs in your stack that go through only 2 quadrants. Don't give me these 4. Don't give me C, J, M, or Q, and we know Q is bad anyway. But don't give me C, J, or M. We already got those. Look for more. Look for more graphs that go through only 2 quadrants. And again, write the letters down in your book there so that you have it and that we can keep using our graphs. Hit pause to work this out. Hit play to check your work. All right, so I was going through my stack and I found quite a few that only went through 2 quadrants. F only goes through 2 quadrants. Now, it's weird because it's the 1st and the 3rd. They're not next to each other, but it only goes through 2 quadrants, even with those arrows going forever. Graph H, 1, 2 quadrants. Yep. Graph I, because it flattens out here at 0. Yeah, so it only does 1, 2 quadrants. That was a tricky one. Graph K, 1st and 4th quadrants, only 2. Graph O actually also only goes through 2 quadrants, quadrants 1 and 4. And of course, graph R only goes through 2 quadrants right next to each other, quadrants 1 and 2. So I'm going to write graphs F, H, I, K, O, and R. They all only go through 2 quadrants. Now, this is where we get tricky. Let's go to the next page where we get tricky. Let's talk about Judy. So Judy grouped these graphs together, but did not provide any rationale. She did not give any reason for this group. We have graphs D, K, and O. So my question to you is, what do you notice about these graphs? She didn't give us a reason for why she put them in a group together. Maybe you notice something. So go ahead and jot down what you notice and hit pause to do that, and then hit play to keep going. So one of the things I noticed is that all 3 of these graphs were in quadrants 1 and 4, 1 and 4, 1 and 4. And D went a little further, right? D was in quadrants 2 and 3 as well. But here's what this means. In each graph, for at least one value of X, there's more than one value of Y. For example, let's see if I can explain this a little better. For example, if I were to pick the number 2 on my X-axis, here's the number 2 on my X-axis. I have a positive Y value and a negative Y value. I have 2. There's more than one Y value here. If I go to 2 on my X-axis here, same thing. I have a positive Y value and a negative Y value. I have more than one Y value at X equals 2. And look at this one, X equals 2. Oh my gosh, I have like infinite Y values. Anywhere up above, anywhere below, so many. So I noticed that in each graph, somewhere there's an X value that has more than one value of Y. Oh my. And we can take this a little further. Maybe that's not what you noticed. Maybe you noticed something else. Maybe you noticed each of these graphs has a horizontal axis of symmetry. Remember earlier we were talking about a vertical axis of symmetry? All of these have a horizontal axis of symmetry. I can slice it horizontally through the middle, horizontally through the middle, horizontally through the middle. So maybe that's what you noticed. I don't know. Maybe you noticed something else entirely. Who can say? But let's come down to our last question here, question B. What rationale could Judy have provided? What rationale do you think Judy gave for grouping these graphs together? There's a lot of possibilities. Give me what you're thinking. Go ahead and write it down and then hit pause to write it down, hit play to keep the discussion going. All right, people. that Y value thing was super bugging me. And I don't know if you remember from last year because it's been a little while, but remember how X's aren't supposed to have more than one Y value? That when that happens, we say they are not functions. So I thought maybe Judy's rationale was that the graphs are not functions because I kept finding X values where I'm like, oh, is it that Y value or is it that one? I kept getting more than one. So I said the graphs are not functions. You may have given a different reason, but that's just what my brain saw. And if you're not sure what I'm talking about when I say function, don't panic. It's coming up in future lessons. We're going to get you guys there. As always, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, email me, come see me during office hours, come talk to me. I'm here to help you out, and I'll see you guys later. Bye.